Okay, before we get started, everybody should have an index card in front of them, and you should have a piece of paper that says Unit 1, Lesson 9, formula for the area of a triangle. Does everybody have those two things? Okay, I also need you to get out a highlighter. Doesn't matter what color, get out one highlighter, and then put everything else on the floor. Okay, put everything else on the floor. Yesterday we did a lesson to kind of get you to understand the formulas of parallelogram and triangle and where they come from. Today we're just focusing on triangles. Okay? Who can, and you don't have to write this anywhere, I'm just seeing if you remember, who can tell me the formula for either one of them, for one of the shapes? Jack? Okay, area equals base times height. Guys agree? Wrong. Reese? That's for a square. Side times side is for a square. That is a formula we learned yesterday, but that one is not for a triangle. Naomi? Yeah, 1/2 base times height, or base times height divided by 2. And here's why, just to refresh your memory. Well, let's go ahead and do the other one. What's the other one for a parallelogram? I'm just going to put P-A-R-A. For a parallelogram, Reese? Cam? Base times height. Now, what is the only difference between those two formulas? Callan? Yeah, triangle you have to divide by 2. If I draw up a parallelogram, and this isn't going to be perfect because I'm just... There's a parallelogram. If I break it in half, what shape do I have? A triangle. So the formulas should make sense. Parallelogram is base times height. Triangle is half of that. So 1/2 base times height, or you can take the base times the height and divide it by 2. Again, we're not drawing on the index cards. That's not what they're for. We're going to focus on just triangles today because there's some stuff we need practice with. If we practice it with triangles, we won't need to practice it as much with parallelograms. Okay? So the piece of paper in front of you, I want you to write your name at the top. These are going to be our notes today, and this is actually straight from the 6th grade math book, the math book you're going to have next year. I'm trying to get you used to the terminology because that's the hardest part about it, is the way the problems are worded, and there's not as much fluency. It's a lot more in-depth problems, but there's fewer of them to do. So let me pull this up. Before we start on the problems that are there, we're going to take some notes over on the side, so in the margin. I'm going to move this. You guys are going to take notes like kind of right over here next to C and F. Oops, mine just shifted. Okay, you guys have some white space over here. We're going to take some notes over there. What do you think, or what did we talk about yesterday? What's important about triangles? Jack? Some of them do. Let me rephrase that. When we are finding area of triangles, what's important? Cam? You need to find the base and the height. Okay, so we're going to write this over to the side. To calculate area, you need the base and the height. To calculate area, you need to find the base and the height. That is the hardest part. The base is usually easy. The height is the tricky one sometimes. And that's what our whole lesson is on today, is being able to pick out the base and the height on triangles. Now, something I don't think I mentioned yesterday, but it is very important, is the base can be any side. Okay, it doesn't have to be a particular side. We could call any side the base. We would just have to find the height that goes with that base, and we're going to practice that today. The base can be any side. What has to be true about the base and the height, Nolan? They have to form a right angle. That's how we decide what our height is it has to form a right angle with the base. So the base can be any side. The height must form a right angle with the base. I'm going to abbreviate with, just a W with a slash is the abbreviation for with. So the height must form a right angle with the base. An index card is a very, very useful tool when you're picking out your base and your height. The base is any side. The height, how can an index card help you pick out where the height is? Emmett?
You could see where the base is and see how high it is.
Okay. What are there 4 of on an index card?
Sides.
There are 4 sides, but that's not important when we're finding base and there's 4 right angles. So if you line up one side of the index card with your base and you put it in the corner, the other one should help you find your height. I'm going to help you line it up and show you how you can use this. Do you have to have an index card? No. Any piece of paper would work because unless you ripped it, all 4 corners are right angles. So this is a very useful tool when you're picking out bases and heights in any shape, not just triangles, but we're going to use it today. Just wait a minute, okay? Okay, so that's the important part. What I want you to do on this first question, I'm going to make mine a little bit smaller for a second. It says, oh, now I'm frozen. Wait till my little dot comes back. Oh, my dot's back, okay. Still frozen. I know, but I have to make sure it's recording still. There we go. Okay, so select all the drawings in which a corresponding height h for a given base b is correctly identified. All it's asking is which ones are labeled properly. This is where your highlighter comes in. Can we visualize, whenever I visualize a right angle, is that something we're all capable of doing? Yes. If I had to give a letter in the alphabet to that picture in your head, what letter would it be?
L.
Capital L, okay? So we can all visualize right angles. That's where the highlighter comes into play. When you're doing your bases and your heights, we're going to physically highlight them because that's an easy visual. If it does not look like a right angle, do you properly have your base and your height labeled? No, okay? So we're using our highlighters because we all know what a right angle looks like. We're going to use our highlighters to help us see them. So I want you to pick up your highlighter. On part A, oh, now I'm got something crazy going on here. Oh my goodness. Now I'm only zooming. Freeze. Unfreeze. Okay, now crazy stuff's, there we go. Okay, with your highlighter, mine's going to be small for a second because my board's doing crazy things. I want you to highlight the base. So just highlight the side that they have labeled the base. Highlight the side that they have labeled the height, which is this. What are some things you notice about that side that they have highlighted? It's not inside the triangle. If I said, Jalen, come up here and I want to measure you, do I have to measure like right here down the front of her? No. Could I measure over to the side of her? Could I still appropriately measure her height? Yeah, and actually, I don't know if you guys have ever noticed it. On my door, it is kind of labeled. It's old and kind of wearing off. But if I'm walking past and someone's paying attention, could they give my height even though I'm not directly in front of those letters and those numbers? Yeah, where else do you see stuff like this? Anybody ever noticed it?
Oh, I have Casey's.
Why do you think Casey's has that on the door? Anybody know? Anybody know? Briley?
Maybe because, to see if you're, too young.
No, not to see if you're young, because are there tall people that are young, like Harper? Are there short people that are old? Logan?
Somebody robs the store so they can tell what their height is.
Exactly. It's so if someone like robs the store or like the cameras are usually focused right there, so as that person goes by, they can give an accurate height and description of that person. That's why you see it at most gas stations. Okay, most of us just see it, but the person doesn't have to stand directly in front of it for them to know, oh, they're 6'2". They just have to walk by the side. So can we measure heights out to the side? Yes, okay? That's one thing to take away from this problem. The height, we can measure it out to the side. Sometimes it's a little bit harder. If I told you to measure the height of that triangle, where would you probably measure, Emmett?
I would measure from the corner.
What corner?
The bottom.
Okay, he's saying he would probably measure from here to where?
Right to the B.
Straight up to the B. I want everybody to use your index card, line it up to where the corner, I'm going to try and draw in my index card here. My index card is black. Line it up to where the corner of your index card is right on this corner. And it kind of like pretend that's your index card. And then use your highlighter to draw in the height right there. Okay, so lay your index card down. And I always put a point at the corner to where I know where my index card needs to start. That gives me a good visual. And then make it go straight up and keep it flat with this top line. And then you can trace in that height right there. Again, you're just doing the pink. The black is my index card because I don't have an index card that I can physically move up there. I'm going to get rid of all this. And then I'm just going to, this is what kind of what yours should look like when you're done. Okay? Now, does my new pink line, is it the same size as that pink line on the outside? Yes. Okay? It's the same height. It's the same length. So either one of those would be the appropriate height. Where else could I measure the height on this problem? Anybody see another place I could measure the height? Carter?
I have a question on number A. How would you do that? Line up the index card.
So you put, I just tried to draw mine because I don't have an index card.
Would you draw on?
No, you trace along the line. So look, here's my index card. I have a piece of paper, okay? I put a dot right there at the point, and you're lining your index card up on that point. And here, you gotta keep that, this corner is a right angle. So if I line up my right angle in that corner, then I can just trace my index card down. Again, when I hold stuff up here, I have too many touch points. So I can't actually hold anything up there and trace it. Does that make sense? Now, Jack, can you answer that question? Where else could I measure my height? Yeah, could I do it on the left side just like they did it on the right side? Okay, let's go ahead and draw in that one. So go straight down. How do I know when to stop? Yeah, it's this, and that's it. Usually if you see a dotted line, does anybody know what that means? Yeah, it's really not there. It's like an imaginary line that we're using for a purpose, but it's not part of the shape. So for this one shape, for that one base, I could measure any of those three distances to get the height. Would they all be the same number? Yes, if I measured correctly. So A works because they're saying which base and height is a good one. Which one is labeled appropriately. So A works. On B, let's just highlight the base and the height that they gave us. Oops, that's blue. I'm going to highlight with pink so it stands out a little more. There's my base. There's my height. Do those two lines form a right angle?
Yes.
So is that an appropriate base and height? Yes. So let's circle that one. Let's highlight the base and the height on C. Do those two lines form a right angle? No, they currently don't even cross. When they did cross, if they crossed, it would be like way out here. Is that a right angle? Nope. So this one is not appropriate, but let's go ahead and draw in. Where could we draw the height? Paxton? We have to use the base that is given. These triangles are tricky. Take your paper and rotate it to where this one, and again, I can't rotate mine up here. Rotate it to where this B is like flat right there. Like rotate your paper this way to where that B is flat, and sometimes that helps. And if I said, now measure how tall that triangle is, Jalen, where could you measure? So here's my base. Where would I have to measure to? Cam?
Top left corner.
Right here. Do you guys all agree? Yes. Now, use your index card. Use your index card. Put the actually put the one side of your index card flat on this line. And then make it go up. This is my index card that I'm drawing in. You put your index card flat, run it along that flat side till it lines up with your point there. And that's how you know where to draw your height. And then we're going to draw our height right there. And then when you remove your index card, you should see a right angle. Okay, here, let me try and show you with my paper. Instead of drawing the index card, ignore the black there. Put a point on the spot that you think would give me the highest point of that triangle. Here's my index card. Lay it, it has to be flat on the bottom of that line. Slide it up till you hit that point. See right there how my bottom is flat and I'm hitting my point? That's where you would draw your line. It takes practice, that's why we're doing it. So the one given, is that an appropriate height for that triangle? No, we drew in the appropriate height. Jack?
Or you could just go
From where?
from where the B is.
That's what we did, was go straight up right here, was the height that we drew in. Could I do this one out to the side? Could I draw my height right there? Yeah, because there would be a right angle. It doesn't look very right angle in my picture. Okay, let's look at D. Highlight the base. Highlight the height. Do we see a right angle? Yes. D is good. What about E? Let's highlight our base. Highlight our height. Is that a right angle? Chase, where could I draw my height in this one to make it work? If I said, how tall is that triangle? What? I always try on these ones, I always make that bottom side flat. So if that's my base, I turn my paper to where it looks more like this, to where this is the base down here and it's flat. That just makes it easier when you're working it. And you guys can rotate your paper. I can't rotate my board. Nolan?
Top right corner.
Okay, so I could go up there. So I can measure from there up to here. So it would be, it's just hard to do it without an index card. This one wouldn't be probably straight. Like it was not always necessarily in the middle. You just have to use your index card to figure out exactly where you can draw it to form that right angle. That should be pink. Okay, that's a more appropriate height for that one. Okay, and I can see with my index card that that right there is a right angle. There's another one right there. Okay, what about F? If I highlight my base and my height, does it form a right angle?
Yes.
Yes, so F is good. So yeah, A, B, D, and F were all good, and we fixed the other two. The ones that are circled. A, B, D, and F were good the way they were. And we fixed C and E. Okay, let's look down at number 2. Number 2 has us pick out base and height and then find the area, because that's the whole purpose of picking out the base and the height. I can make this a little bit bigger now. Now, you have a little bit more room to write under A, but you're still going to have to write small, okay? Nolan, you with me? Says, for each triangle, a base and its corresponding height are labeled. Find the area of each triangle. They're labeled, but what do I have to do? Kinley? Yeah, I have to count to figure out the base and the height. Briley, count the base on A. Paxton, count the height on A. Naomi, count the base on B. Nolan, count the height on B. Logan, count the base on C. Ethan, count the height on C. Carter, count the height on A. Jalen, base on A. Emmett, base on B. Addie, height on B. Cooper, base on C. Livy, height on C. If I didn't pick you, pick one and you'll triple check them. Okay, if I didn't pick you, pick one of those 6 numbers and count it and see if we can all agree on them. Okay, who were my 2 that had my height for A? Height for A. Paxton, what'd you come up with? 6. Carter, do you agree? Okay, so let's all label that this is 6. What is my label if I don't see one? Emmett?
Something squared.
Okay, it's not something that my answer will be something square, but I'm asking for like, what do I put if I don't know feet or yards or? Callan? Units, I just put a U. So my height is 6 units. The base, who were my bases for number 1? Briley? 4. Jalen, do you agree? Okay, so let's write that this is 4 units. Let's go ahead and fill these in for all the triangles before we get started. Who was my base for B? Base for B. Emmett, what'd you come up with? 8. Naomi, do you agree? Okay, so let's write 8 units. My height for B. Nolan? 4. Who was the other one? Do you agree with him? 1, 2, 3, 4. I agree. So 4 units. Now, the base for C is actually, some people miss this one if they highlight first. Cooper, what'd you come up with for the base for C?
Like 6 or something.
6 is correct. Why would some people put 8? Why would some people put 8? Emmett?
Because it's like, it's still going.
Because they find the height out to the side. But when you're counting, you only count the the side of the triangle. You don't go those extra two because that's not part of the triangle. We just used it to find the height. So that one is 6 units. What is my height in this one? Who was this? Livy? So you just count. So we're looking at this line. So there's 1, 2, 3, 4. Okay, so my height is 4 units. Let's double check with our highlighter that they have the appropriate base and height. What should I see when I highlight the base and the height?
Highlighter, right angle.
Right angles. Let's go through quickly and do those. Base, height, I see a right angle. Base, height, I see right angles. Base, here's my height. If I draw it like that, I don't quite see it. Why not? Kinley? Yeah, so I kind of have to imagine, and this is where the dotted line comes in. If I dot that on out, now do I see a right angle? Yes. Okay, so those are the ones that trick people. Now, just like with rectangles, we start with our formula. So we're going to say triangle A, and you're going to have to write small. I'm just going to work across because of the amount of space they give us. What's my formula for area of a triangle? Jack? Just give me one of them. Okay, so 1/2 B times H. Okay, we can use that one. 1/2 times base times height. So when we substitute, the 1/2 doesn't change. I already know that that's always a 1/2. So I just always copy down 1/2. What was my base, Stella? In 4. What is my height? Kanan? In triangle A, what is my height? 6. Okay, now, even though it's fractions, these are mental math fractions if they're all even numbers, and these are. Nolan, what is 1/2 of 4? 2. Notice in place of the multiplication sign, I said of, because of means multiply. But when I say 1/2 of 4, you guys immediately think 2. If I would have said what is 1/2 times 4, you would have been like, let me get a piece of paper. Okay? So use that to your advantage. 1/2 of 4 is 2. What is 2 times 6? 12. So the area of triangle A is 12 square units. For B, we're going to use the other formula just to show you they're both about the same. So for B, we're going to do base times height divided by 2. Rewrite. And again, I'm working across instead of down because they really don't give us much space here. Ethan, for B, what's my base?
8.
What's my height? 4. So I have 8 times 4 divided by 2. What is 8 times 4, Chase? 32. Anybody know what 32 divided by 2 is? 16. What's my label? Square units. Good job. Okay, so are the formulas very, very similar? Yeah. It doesn't matter which one you use. Whichever one you're more comfortable with is the one I suggest using. Okay, for triangle C. A equals, Addie, which formula you want to use? 1/2 base times height or base times height divided by 2? Okay, so base times height divided by 2. And again, it doesn't matter. Substitute in what we know. Briley, what's my base? What's my height?
Base is 6 and then the height is 5.
4.
Not 4.
Cooper, what's 6 times 4? 24 divided by 2?
12.
It's 12 square units. Now, looking at triangle A and triangle C, are they the same triangle? No, but they have the same area. What does that mean? What does that mean, Paxton?
Like,
Yeah, they just take up the same amount of space. That's really all that it tells us. Doesn't mean they're the exact same triangle. And on this one, the base and the height are the same. Okay, but they don't have to look the same to have the same area. We're going to move on. We're going to skip B. This number 3, your question's at the bottom of the front, the picture's on the back. So you'll have to flip it over to the back to see the picture. Here is a right triangle. Name a corresponding height for each base. So on this problem, it's showing us that any side can be the base. Okay? Sometimes it makes our life easier if we pick one base rather than one of the other sides as the base. So let's start with side D. Okay, everybody highlight side D. Everybody highlight side D. If I said side D is your base, where would you measure to find the height? If I said, Emmett, measure how tall that triangle is, where would you measure it? To the point, right? Everybody put a dot right there. Use your index card. Put your index card flat. I'm going to draw mine in black. Put it flat along here. And I always start over to the side. Here's my index card. And then just slide it over until it lines up perfectly, like right there. And I even went too far. Again, it's harder to do because I don't have an index. So you're just sliding it over, and then that's where you trace. That tells you where to trace your height. Okay, and I have a lot of extra markings up here because I can't physically slide an index card. Okay, so does everybody agree that that right there would be a good height if D was my base? Okay, but do they have that labeled as a height?
No.
Where do they have that same distance labeled, Emmett? G out to the side. Is that the same distance? Yes. Is it okay if they measured it out to the side rather than down the center? Yeah, it just makes it a little bit more challenging. So for if side D is the base, then the height would be G. There's lots of answers. This isn't a multiple choice question. Okay, now take your pencil, just because you only have one highlighter out, squiggle in side E. Okay, I'm going to actually get rid of all of my writing and then redo it. So I'm going to squiggle in side E. So now we're saying side E is the base, because remember, any side can be the base. If side E is the base, which side has to be the height? Cooper?
Side D.
What are we looking for? What do the base and the height have to form? A right angle. Look for a right angle. Side E makes a right angle with what? Which side?
D.
Here's D. Is this a right angle right there? Where do we see a right angle, Lena? F, right here. There's our right angle. So side E and F form a right angle. So if I call side E my base, my height would equal F. What if side F is my base? E would be the height. Okay, that problem's kind of confusing because they make you find 3 different ones in one triangle, but you could do that on any triangle. One of them is usually easier than the other 2. Stella?
Will we have a problem like that?
No, we're getting ready to do some like what you'll see tonight. Okay? I actually have to switch to a new page. Your homework will look like these next examples, and we're actually going to do 3 more and then we're done. Let me get to the next section. I just have to find it. I kind of cut and pasted some different notes together for you guys. I think they are. There's our note card. Right here, right?
Yeah.
Okay. This is like what your homework will look like. You will get a worksheet and there'll be triangles on it and the base will be labeled. What do you think you're going to have to do? Callan? Draw in the appropriate height. So you're going to use your highlighters. You're going to use your index cards. Let's start by highlighting the base that they give us. And on this one, if I was finding the area of this one and I got to pick my base, would I choose that one?
No.
Why would I choose any of the other two sides, Jalen?
Because there's a right angle.
Yeah, the other two make a right angle. So if I had a choice, I would pick like this is my base. But I don't have a choice. It's saying if that's the base, what is the height? If that is the base, how can I find my height? Where would I draw my height? Emmett?
You would bring it down to the bottom left.
Okay, yeah, I need to. So everybody put a point right here. Use your index card. And here, I'm going to use Jalen's to kind of show you. Put your index card flat on the bottom, then just kind of run it along the side, and that's not long enough for mine, till it covers that point to where you can draw a straight line. Let me try and do it with a piece of paper to show you if you're still confused. Okay, because the bottom side has to be flat on that base. So I'm going to take it, I'm going to run it along the base till I can draw. See how when I get right here, I can connect my dot at the top and my base is flat. So I could draw my height right there, show that it makes right angles, and label it with an H. Okay, what about the next one? Kanan, what do I need to do first? Highlight my base. Where is the highest point of that triangle? At the top. Okay, then you can use your index card to come straight down to the base, form our right angles, and label it our height. The next one's kind of tricky. Paxton, what might I need to do on this next one? One, if this were me, I wouldn't choose that side of this base. I would choose the bottom side because that'd be a lot easier to calculate the height. So I'm going to just try and draw it for you, what it would look like. That would make it go out slightly. So if this was the base, and all I did is I kind of tried to rotate it, it would kind of look like that. So if it looked like that, where would be the easiest place to find the height? Nolan?
The bottom right corner.
What'd you say?
Like the bottom corner.
Okay, he's saying like maybe like right here. So use your index card. Is that a right angle? No, but could we use that to help us find the height? How?
We draw a line from there to the middle across.
Okay, so where are you going? Are you going on the outside or are you going kind of up? Okay, so Logan is saying and again, this one's a hard one. I don't like this one. I would have just said this is my base. There's my height. That makes my base height. Makes your life a lot easier. They picked a hard base. So Logan is saying if you put your index card right there, and again, if I draw this, let me draw it, and then you guys can say, no, that can't be right. If I draw that, there's a right angle. What is really weird about that? Could that be the height of that triangle? No, it just looks weird. So here's what we're going to do for this one because they picked the hardest one possible. We're going to label this the B because it makes our life a lot easier. And when you're finding area, any side can be the base. Mark that one out. They made our life difficult. How can we measure the height now? And all, is it the same triangle? Yes. So no matter how we do it, we will get the same area. Did that just make the problem a lot easier? Yes. Cam, where are we going to draw the height?
Like draw the base out more and draw the height.
Yeah, we're going to draw our imaginary base out a little bit more. And then we're going to do this, the height, right there. You can just do this in pencil because I know you already have extra highlighting. Does that make the problem easier? Emmett.
So could we do the same thing on the right to the base out? Like draw straight up and then like the lines.
Yeah. Yep. Okay, so your homework looks just like that. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. You will highlight the base, draw in your height with highlighter. So when I look at this tomorrow, I should be able to see right away. You should be able to hold up your paper and someone behind you can be like, right angle, right angle, right angle, right angle. Nope, that one's wrong. Okay? Does that make sense?
Yeah.